Okay, hello everybody. Welcome back to 2023 and to the continuation of our GBO colloquium series. Today we have a really interesting talk by our very own Toney Winter, who'll be sharing with us some insights into the life cycle of among others, GBT project proposal, the ins and outs, what happens when you press submit. So please enlighten us, Toney. And if you have questions, we'll save them for the end. If you're on Zoom, please feel free to either put them in the chat or request to unmute yourself at the end. Yep. Take it away.
And if you want to ask questions during the talk, please do so. This talk is a little bit of a Dr. Jekyll and Mr. Hyde talk. I wrote the slides for the novice so they could be shared out. Novices could get a little bit more information that way, but as I speak, I'm going to assume everybody knows most of the parts of a proposal and everything and kind of quickly go through those parts. So we'll go through the proposal call, what parts constitute a proposal. Most of my tips will be in those sections. And then I want to spend most of the time going over the proposal review process, because that's the part most people kind of peripheral see and don't know anything that goes underneath the hoods for that. So the talks are online, the links here. At the bottom of this page, I also have it on the last slide. So you want to grab those at some point. So really quickly, we have 2 proposal calls a year, one due in early February, one due in early March. These go out and are announced to the community in various different ways. And one of my first tips is always read the proposal call. It doesn't change much, but the changes are important because new instruments or backends can go away or come. That's important to know. New policies can be announced in the proposal call. Right now, there probably will be some new ones that come up in the 24A call. So make sure you're aware of that, along with some policy changes that come along. So it's always important to go through there. I know it's boring to reread the same thing year after year after year, but you got to catch the important changes, and it's hard to write something we try to highlight the important changes for people, but you still need to go in there and look, be careful about it. So there's different types of proposals. We have regular proposals. Those are submitted at the February and August deadlines. We also have trigger proposals. Those are for sources who you don't know when they're going to flare up and appear, but you kind of know they exist a priority. So you can propose for those, and then when they do flare, say, hey, I need to observe this now. And if your project was approved, you can get those. So this might be something like a repeating FRB, gravitational wave event, or comet. Then we also have large proposals. So we have different conditions for that depending on the weather. So if you're below 8 gigahertz, you can be scheduled in any weather. That's 400 hours or a project longer than a year. If we jump up to excellent weather, it's only 100 hours or anything can be scheduled that you want to be considered for more than a year. One of my next tips is the TAC actually gets tired and weary of seeing the same proposal over and over and over and over, year after year after year. So if you're going to have a project that's going to last 3-4 years, you really should consider submitting it as a large project. TAC sees it once. If they like it, great. You have your time for the next 3-4 years, whatever they decide. So, but if you submit it every year, you might get okay grades the first 2. The TAC starts getting tired of seeing the proposal. The 3rd year, you get a little lower grade. And the 4th year, they say, no, we're done with it. So there's a balance there. I can't tell you where that line is. It's a lot of gray area for this, but just something for people to be aware of. We also have a DDT time, so targeted opportunities. These are for unexpected events that pop up that you couldn't have predicted the phenomena. You also have exploratory time, so if you're trying to develop a new technique and say, oh, I need to try this to be able to submit a large proposal later on or something like that, that's appropriate to put in for exploratory time. And then there is an educational part, but that typically has to be tied to the EPO activities for the observatory. So just remember, when you submit your proposal, the TAC will always give preference to a regular proposal or triggered proposal over a DDT. That works in two ways. That if a DDT is accepted and the TAC's accepted a regular proposal for the same object or same type of event, you don't know which is going to trigger on which, and sometimes two trigger on the same event. The regular proposal or triggered proposal is going to have preference over the DDT. But if a regular proposal got rejected, you can't submit a DDT for the exact same observations with the exact same science argument, because the TAC's already reviewed that and say, no, that's not going to be part of our program. So you resubmitting, you have to have a new argument or a new science case to do those observations. And also DDTs have to explain why they couldn't have been submitted at the regular deadline. So if you came in and say, oh, I've had a chance to observe this spectral line for this source that we've known its existence, but we didn't know the spectral line a week after the deadline, well, that gets kind of sketchy. And that's not really a good reason why to submit it as a DDT rather than as a regular proposal. All right, there are a lot of tools available for proposers. So you have the help desk. So if you have questions or need help developing your proposal, or need clarifications for how to enter things into your proposal, please use the help desk. We try to keep an eye on that. At least during normal work hours, the people with eyes on it. We try to check it quite a bit outside of work hours, though we all have to sleep at certain times. But we do try to keep up with that pretty well. If you want to see if someone's done that type of observation before, the data already exists. There's a proposal finder tool. You can go in there and it'll show you all the accepted proposals, and you can search for those that way. Archive access tool would actually give you access to observations, so you can look and see if an observation of a particular source has happened. Though that's in some state of flux right now, so it's not complete for the GBT yet. We're still working on that. So just take looking at the results of the access archive tool with a grain of salt right now. We also have the sensitivity calculator, which can help you determine the amount of observing time to request. Also the mapping calculator to figure out how long it's going to take you to map the areas that you want to do. And then of course you have to use the proposal submission tool to submit your proposal for review. So just real quick, proposal, you just have your typical stuff on the cover page, the title and the abstract. One important thing is we do have joint proposals. Joint with the VLA and VLBA and GBT are done internally. So you submit a proposal to each one of those within the PST. That undergoes one review, even though for various historic reasons, you have to submit the proposal a couple times with the resources changed between the proposals. But it's only one review for, how many ever you have to submit. We do have external agreements with HST, Swift, Chandra, and XMM Newton, where you submit to the primary telescope and request time on the other one. That's reviewed just once by the TAC of the primary telescope, and if they award time, you can get time on both instruments that way. And we do have other agreements that are probably coming online within the next year that will be exciting and interesting to the community and provide some great opportunities. So another important thing is to list related proposals. So sometimes with these people propose several proposals, or as the research progresses and you have to look for a new thing to answer a question that arose from your previous proposal, it's helpful to list what proposals in the past that you've had. The TAC might find that relevant. So if you fill that field out, that helps in your review process with the TAC, so they can follow the trail and see what other previous, there is turnover in the TAC every 3-4 years. It's a completely different TAC, has different membership. So having that trail and providing that easily for the TAC to find can help things out quite a bit. We have 9 different science categories. Some are more important to one telescope, like the 2 AGN are more important to VLA and VLBA than to the GBT, though we do get a few in. And then you have some things like interstellar medium that's pretty heavy for the GBT, but not for the other telescopes. So it's kind of a blend because the TAC reviews proposals for not only the GBT, but also for the VLA and VLBA at the same time. So they're reviewed together. So, and we do update those science categories as things get overloaded. We split a couple categories twice. We try to keep an eye on what's being proposed and everything. And if there's suddenly a new branch of science and radio astronomy that came along that warranted its own science category, we put that in at some point. Just remember, because those categories are so broad and because they encompass many telescopes, you're not going to have experts reviewing your proposal. You might have one reviewing it, but the other people in the panel are going to be knowledgeable, but not experts in your field. So you need to write your proposal for a general science audience. And just know that a couple of the things that get caught quite often are people don't explain why their project's important for astronomy. They'll say, hey, I got this neat thing, and get stuck in the jargon, go on through, and never say, this is why this is important for all of astronomy. So they've stuck in their own field thinking experts are going to review the proposal, but haven't given the big, broader picture to the general audience of why it's important. Another common mistake is that people will submit FRBs to the pulsar compact object when they should go to the gravitational wave and interject transients. That is just a split made. I know there's a gray area with magnetars and FRBs, but you got to, if it's primarily FRB, it needs to go to the GWT science category. So we have author list on the proposer of the proposal. You can designate the principal investigator, the contact, and just note that dissertation plans are associated with the author. And you want to keep up your profile information because that's what we use to contact you. So if you've changed institutions, make sure to go back in there and change your contact information and keep your profile up to date. Otherwise, we can't track you down. There's something like 10,000 users in the database or something of that order, and we can't, make all the changes. And also make sure you keep your dissertation plan up to date. We have people who, oh, I'm graduating in the middle of the semester and they haven't updated their plan, and the panel might want to give the proposal a boost because it's a dissertation, and they see, oh, you're not, you've already graduated 2 years ago because you didn't update things or things like that. So that's a pretty annoying thing if to the TAC if you haven't kept this up to date. Source lists, you have to include all your sources that are known. If you come up with sources later on, you can contact the schedulers and potentially have those added into your project. But at least at the start, you want to have all sources listed. This is primarily for your protection on your project because we don't want people to come in and scoop you. So we check for source conflicts that no one else is doing those observations. And the only way to be able to do that, to make sure that the first person that asks for those observations actually gets it, is if everybody provides the complete source list. Your source lists are confidential. They don't get published. They don't go out into the public. And so just know that we don't tolerate intentionally obscuring the source positions. We've had proposals do that, and we've rejected them because of that when they've been caught. And if you don't know the sources, putting in RA0 and deck of 0 is just fine. Resources, that just defines the receiver in the back end that you're going to go or use. Those can be broken up into groups. When you create the sessions, goes on the telescope, you use a resource group and a source group and combine those together. So these sessions just do that, provide how much time you want to observe per epoch, how many epochs, and various other parts about the observations that you want to do. Creating sessions is an art. You typically want to keep them to about 3 to 6 hours long for the GBT because it gets pretty difficult to schedule longer ones. The longer you go, the more difficult it gets. Just also remember the GBT is scheduled in 15-minute intervals. So you want whatever time you request to be a multiple of 15 minutes for each session that you're asking for. I typically want to keep things, sources together within 20 degrees in deck, 2 to 3 hours in the RA into one source group. So they go into one session. One thing to keep in mind, you do get long slews when the declination crosses the latitude of the GBT because the telescope has to swing 180 degrees or, have pretty long slews. And so if you can split your sources up by declination of where the GBT latitude is, that can help if you have a large number of sources. Just reduces the amount of overhead from slew time. So a lot of people will put all their sources in all their sessions when they intended only one source per session because they use one source group rather than many source groups. So that's a place where people mess up quite a bit. And also, if you propose a 30-hour session and just overhead time for the start of that session, well, you're going to lose out. That's going to get broken up into maybe 10 3-hour sessions. You've only included overhead for one, and you should have included it for 10. So just be careful about how long your sessions are and how you want to include overhead for that. So it's just another common mistake. Technical justifications are required. You need to fill it out. You don't have to fill out every field. Some of them won't pertain to your proposal. So you don't have to provide pulsar information if you're doing a spectral line observation of H1. So just put NA in that field. That's perfectly legit. Don't put NA for all the fields. We know that you just skip that whole thing. At least some of the fields are required for all proposals, especially the justification for the amount of observing time you want. And, common mistake is for fixed time observations or ones that are temporally constrained, such as I need phase at this to observe at this phase of an orbit. Provide all those times during the semester when you're asking for time. The list might be long, in which case just submit the formula and explain and define all the values. We're not going to go out to a website or contact the author afterwards, figure out this time, because we have to use only the information in the proposal to figure out before the TAC meeting whether we can schedule your proposal or not. We can't go out and contact you. That's a conflict of interest. So make sure your proposal contains all the information needed for constraints on your observing. Also, just remember, we provide the sensitivity calculator, but it's not required that you use it when you submit the proposal. You can do your own sensitivity calculation. There are observations where the sensitivity calculator isn't the right tool to use to calculate how much time you want. So you don't have to include the output of it. It's recommended that you do. Just makes getting your proposal through a lot more higher chance to get it through because we can understand that a bit more. But if you don't use the sensitivity calculator and include the results, make sure you include all the equations you use, define all the terms, and provide all the information so that we can recreate your sensitivity calculation. We do check those for all the proposals. Same goes for mapping, using the mapping calculator, and its outputs are recommended but not required as long as you provide all the information you use. RFI is an important area to address in the technical observation. We now have examples of RFI in all the bands observed by the GBT. That time has come. It's no longer, oh, there's no RFI above 90 gigahertz. I don't have to worry about it. There is, it exists. It's out there. It's not much yet, but it's there. Another thing that people mess up a lot are their overheads. Just remember, you have to do the pointing, slewing, receiver changes and everything. Sometimes, higher frequencies, you have to point every few hours or every hour, depending on what you're doing. And just make sure that those things are included. And if you don't use the LST range calculated by the proposal submission tool, explain why you're not doing that. There are valid reasons to skip that and that calculation and provide your own. So just enlighten us as to what you're doing. Your science justification is only about 4 pages long, is only 4 pages for regular DDT and triggered proposals. You get 10 pages for large proposals. Place where people really mess up is it has to be 11-point font or bigger. You need to have 1-inch margins around top, bottom, and the sides. And also it's supposed to be on US letter paper. A lot of people will mess these up. The TAC and the reviewers have the perfect right to say, I'm not going to review this. It's going in the junk pile because you didn't meet these requirements. Or they might, which is what they generally do, is downgrade your proposal score because you didn't meet the requirements. Now we'll get into more of the meat of what I wanted to show people and under the hood in the review process. So approximately 1 month before the proposal deadline, we send out the proposal call. Then for the GBT, roughly 2 weeks before the deadline, we'll provide updates on the status of active projects at the GBT and try to give you an idea of the ones that will end either at the start of the semester or the next semester, to let them know that they need to consider to propose for the upcoming semester. If your project carries through that semester that the proposal deadline is for, we won't contact you because you're already pre-approved for observations through that semester. But the projects which will end before that will contact. So then the first week after the proposal deadline, there's actually a lot of work that has to happen to prepare the proposals for review. We have to have a grace period, for people who are late. Sometimes people are sick. We'll let them get their proposal in. They were because of extenuating circumstances. That's happened once or twice. A lot of times we have to clear up errors in proposals that they won't print, so we can get them reviewed because they have strange characters in them. So we have to fix those. There's all sorts of weird little things that we have to take care of in that first week to prepare. More about that later. Then we give about 3 weeks for the technical and science reviewers to get their individual reviews in. Once we have all those reviews in, we have to prepare all the material, work out what the scores are for each proposal, get that out to the science review panels. Then there's a 2-week period where the science review panels meet. We have to schedule 9 panels twice, so 18 meetings in 2 weeks, and make sure everyone can be there. That's a lot more challenging than you'd ever imagine. Get it done that quickly. Then after the science review panels meet, then we have to come up with the final scores for the proposals, and then figure out which ones we can actually give time to and send that off to the TAC. That takes about 1 or 2 weeks typically. Then the TAC will review the large proposals first in a telecon. That's done because large proposals can have a huge impact on whether we can accept or have to reject other proposals. And so knowing that those results first is very important. And so after the large TAC, our large proposal meeting, we have another week to adjust things and get the information out to the TAC. Then we hold the TAC meeting. After the TAC meeting, we have to take all those, roll them into recommendations to the director. It's actually the director who officially says yes or no on accepting any proposal. The TAC is actually a recommendation to the director. And so then at the director's review, we go over any things that the TAC has raised that they think the director needs to be aware of. And after that, we get to create and send out the disposition letters. So the whole process takes about 3 months, typically, to 3.5 months. So what do we do in that first week? Well, first we have to vet the science categories. Make sure the correct science category was picked. There are gray areas. Like if you're studying the connection between magnetars and FRBs, which does it go in the pulsars or does it go in gravitational wave and transients? We have to make that call. The other thing we do is we want to try to balance the number of proposals in each science review panel. There's a lot of proposals that can fit in gray areas between two panels, and we'll actually move some proposals over to different panels to balance out the loads, because we typically want 30 to 40 proposals per panel. Sometimes it gets out of hand and we have to split them. Like the last time we had a single AGN panel, there were over 90 proposals they had to review. That's a big load to review in a couple of weeks. We also have to determine the technical reviewers for all the proposals during this time, and get those assigned, get the science reviewers assigned to each proposal correctly after we figure out the science category. And then we then let the reviewers know. Then they have to go in and actually say, I'm conflicted on these proposals or not. So if they're conflicted, they can't review them on the individual science reviews. Once all the conflicts are decided, then the panel chairs will assign a primary and secondary reviewer, and then multiple tertiary reviewers responsible for that, reviewing that proposal. And then, so the primary will present that proposal at the science review panel meeting, and they have that meeting, and the secondary and tertiaries also provide reviews during that are factored in. So the individual reviews will always be anonymous. You will not know who the individual science reviewers are. The reason we want to do that is because we don't want to make the individual science reviews public. In the past, that has been done, but we didn't want to do this now because we get more honest reviews if they're anonymous. And also because the reviewer might be afraid of retribution. Just coming to them and saying, hey, why'd you do this? I mean, that actually intimidates the reviewers. It's not bullying, but it's, down that neck of the woods. Now, you declare a PI if you're on the proposal, or declare a conflict if you're on the proposal, if you're in the same department as any person on the proposal. Of course, if you're family, spouse, partner, that's an obvious conflict.
But this affiliation, can I just ask a question? The same department, obviously, we do technical reviews for other people.
Right. These are for the science reviews.
Okay.
The technical reviews are just a few of those because yeah.
Same institution.
Right. Science review, if you're same institution, you're going to flag this as a conflict. Of course, for technical reviews, you have to ignore that for other people. But that's why we have the end one that you don't think you can give a fair or impartial judgment. That really applies with technical reviews. So if your buddy down the hall you really hated and didn't think you could judge it fairly, you should be flagging yourself on that, even though you could do the technical review. That's not really the case around here, but it's there just in case. So if students and advisors can't review each other's papers if it's been within 5 years so that they've been a student or the advisor, and Also, if you've collaborated with somebody in the last 5 years. That obviously doesn't get flagged for the technical reviews, but does for the science reviews. Now, each science reviewer will provide a summary of the proposal, lists the strengths and the weaknesses, and provides a score between 0.1 and 9.9, with 0.1 being the best score, best proposal ever written, 9.9 being the worst proposal ever written. Now, typically, what you have in all of this is pretty obvious. The proposals that are really good. There's, maybe 6 or so out of every semester that really stand out above. And you go, why the heck didn't I think of that? Those proposals are always going to get the high scores. There's a couple of proposals that are obviously badly written and usually in haste in the last hour before the deadline. Those stand out, they get the lowest scores. Most everything else packs up in between, in the middle. And so, everybody who submits proposals is a, bright person, a good writer, has good ideas. And so, they're obviously going to pack in together. So there is a bit of randomness on who the reviewers are that might take your proposal up or down. So just watch certain catchphrases like, we will show that this is this and this, and just never discuss it again. That will get caught almost every time. So if you're going to show something, provide some explanation of how. So that'd be my tip here. Just read your proposal critically and look for the places where you say something that you don't back up in any way. And those are the flags that typically will get caught. Now, the goal for each individual reviewer is to have a average score of 5 and a standard deviation of 2. I think in all the years, we've seen this a couple times. There are groups of certain types of proposers that will always have an average of 2 and a RMS of 1. There's one panel that really specializes in that. That doesn't make it easy to compare scores between proposals, because not every panel member reviews every proposal, because it might be conflicted or various things like that. So it makes it tough to compare between reviewers. So what we do is we actually normalize the score so it does have an average of 5 and a distribution of 2. And that's just simply done by subtracting the mean from of a particular reviewer from their score for a proposal, dividing by the standard deviation, then multiplying by 2, that makes the standard deviation 2, then adding back in 5 as the mean. So now everybody's reviews is on the same scale. All their averages are 5, all their deviations are 2. So we can compare the proposals and know where they fall, even if someone skews high or skews low. We can get that worked out. So it allows fair comparison when we combine all the proposals within a panel from all the different reviewers. At the same time, we've done the technical reviews as the individual reviews. So we're just checking that the proposal is feasible, that the time request is reasonable. We do find issues. It's not syncing the proposal necessarily. Sometimes it is, because it might not be possible to do it. Sometimes there's been a big goof and you don't need 10 hours, you need 10,000 hours. Well, obviously that's not going to get through. That's going to be a big issue. But the technical reviews are really just saying, hey, they made this error. Here's what the time they need would be. Or if there's an alternate setup that would provide better science or things that provide that. The technical review is not changing the science in any way, but they're just offering up possibilities of what the real time needed would be, and if there's a better way to do the proposal that really helps things out without changing the science. So there's a science review panel for each category. So there's, one panel for pulsars, there's one panel for gravitational wave events, one panel for the ISM, and so forth. There's 6 reviewers on each panel, 5 are reviewers, 1 is the chair. And the panel chairs are actually what makes up the TAC. The TAC members are publicly known, but the other 5 members are not. So, like I said, each proposal has a primary reviewer, secondary, and then multiple tertiary reviewers. Yeah.
That's great. How many semesters do the members serve for?
The TAC members will typically serve for about 4 semesters. Panel reviewers will serve for 4 to 6 semesters.
The chair only after you've been.
We typically try to get experienced people who've been through reviews once or twice to be a panel chair. Then we also try to not turn over the whole panel and the whole TAC at one time, because then there's no memory. And memory turns out to be a useful thing for the TAC and getting things through, especially when you have proposals that come in every second semester. So our goal and the way we set this up is to have 3 or more reviewers for every proposal. It depends on conflicts, of course. Typically, we try to make sure there's at least 4 reviewers. Sometimes we can get by with as few as 3. In some rare cases, we get lots of conflicts on a particular proposal. And in those extraordinary circumstances, we do go to the other chairs of other panels and have them provide reviews. So we do have the 3+ reviews for every proposal. So now, each panel will meet twice by telecon during that 2-week period. They will discuss all the proposals. Now, it doesn't mean they get the equal amount of time. So the proposals where the recommendation is, kind of obvious and it's not in a borderline area where they need to make any adjustments or anything. They might just say, anybody have a problem with this? They say no, they move on. There's nothing really contentious about that proposal or anything that needed to be discussed. When a reviewer is conflicted, say they wrote the proposal that's in their panel, they leave the telecon for that time period. Now that we have Zoom, we put them in a room where the panel's not meeting and then bring them back after it's done. The panel during the meeting will also come up with a consensus review, or at least the points for consensus review that the primary reviewer will then write. And this consensus review is the science review panel that you see in your proposal disposition, if I can get it out. During the panel meeting also, they will adjust the score based on their discussions of the particular proposal. So if you had 3 reviewers say this is really great, 1 said it was really bad, and the 3 that says really great can point out to the one that's really bad that they made a mistake, they'll adjust the score up. Or if the one that was really bad was just a better reviewer and caught something the other 3 didn't, they'll downweight it depending on how the discussions go. Not every reviewer is perfect. We know that. And the panel meetings are a way to try to make sure that that doesn't go through the system all the way, that there is some consensus of where this proposal should lie. And it's during the panel meetings that they will typically, for proposals that are part of someone's PhD, will give those proposals a scoring boost at that point and try to get them at the appropriate level. Now, yeah, go ahead.
Large proposals, they are reviewed at a different time. So are they reviewed by the same?
At this point, all the proposals submitted at the regular deadline are going through the same process at the same time.
Yeah.
It's only when we get to the TAC that the large proposals are discussed a little bit earlier. So to be able to compare proposals between the different panels, we also have to make sure that one panel doesn't weight proposals a lot higher than the other. The underlying assumption in here is each science review panel should have an equal chance to get their highest rated proposals onto the telescope. So you want them all on the same scoring range. And the way we do that is by taking the linear ordered ranked list of proposals from the panel. This is the highest, this is second, this is third highest score. And we divide it by the total number of proposals the panel sees and multiply by 10. So you get a score somewhere between 0 and 10. Well, actually, point whatever, something close to 0. And 10 for those proposals. Then you can combine all the proposals from the different panels, and each panel gets the fractional amount of time, depending on how many proposals they had in their panel, that should wind up in the top quartile or top third, or however you want to break it up. It should be equal among the panels, weighted by the number of proposals for each panel. That's why we spend time at the start of the whole process, making sure we try to get the panels leveled out. Because if we have one panel that has 90 proposals and one that has 5, it's tough to make sure that they get good representation at the end. If it's more like 30, 40, then you can do that a lot better. So it's just trying to make the most level playing field we can out of the situation, depending on what's submitted. Now that linear rank score will be what shows up on your disposition letter. At the same time, we're looking at source conflicts. Some of the telescopes can get this to the panels during the panel meetings. Other telescopes have to wait till the TAC meeting. It just depends on how things are going. So for the GBT, if you have requested overlapping frequencies, used to be same receiver, now we have to do overlapping frequencies since we have receivers overlapping each other now. We start off within 3 beam widths because you might be doing mapping or of the same area or something like that. That 3 beam widths will generally catch those cases. We also look if it's the same spectral line, if it's a spectral line project or not. And then we check the proprietary period. If it's been a recently completed project, they still have a year proprietary period. And you shouldn't allow other people to observe that same source in that proprietary period. So that's taken into the search. And we also have to compare different proposals submitted at the same time. There's usually 3 or 4, maybe half a dozen sources that are asked for by different proposers at every deadline. That's just kind of a general average. And so we notice these potential source conflicts and we'll pass them on to the TAC. The TAC actually makes the final decision or recommendation on source conflicts. We'll provide them with some information, but what we think they should do. But they do go in and check to make sure the science goals are the same if they are declaring a source conflict. And also they'll go in and make sure that it really is the same source. That can be tough sometimes with, say, pulsars. They can lie close together. So it's a little bit more challenging to make sure that they are different objects. Takes a little bit more effort, I should say. And so it's a double check on things like that. Now, here's where I spend the bulk of my time is, and the schedulers for other telescopes will spend a good amount of time, is working on the time available to be accepted to hand to the TAC. So what we have to do is go through the active projects at the beginning of the semester and see what's going to get carry over. There are a few projects on the VLA that didn't complete in the last configuration that's coming up. They have to carry over. GBT is a lot more. It's maybe a handful at the VLA, a few. And then with GBT, it could be dozens, literally. So we have to figure those up, what those proposals are, who's going to be ending before that semester, let them know before the deadline that they might want to repropose if they're not going to complete, things like that. Then after the SRP panels meet, but before the TAC is met, we have to run simulations for the rest of the semester because there's still 3-4 months of the semester left that we don't know how the proposals are going to work out. So we run a simulation of the scheduling and do our best guess as to which proposal from that simulation, which proposals will complete, which proposals will carry over, and how much time they have to carry over. It's a guess, but it's the best we can do, figure out what's going to carry over into the next semester that we have to allocate time for. That is not available to be assigned to new proposals. At the same time, we have to actually go through and create a pre-schedule for the next semester. So we have to put things in like the maintenance days. We don't want to schedule too much science because we have maintenance taking up, 8 hours a week. That's important to know. We have to put in shutdowns, for GBT, that's typically Thanksgiving, Christmas, painting in the summer, and at least for the next 4-ish years, track and grout work. They'll have significant shutdowns we have to take into account. Then we also have to make sure that we set aside time for our contracted time. So our sponsors like Nanograv and Breakthrough Listen, we have to make sure that they're going to get their time during this coming semester. And then we also have fixed and monitoring projects that carry over. We have to make sure that they'll get their time. So you always have to put all these onto a schedule first. That takes a good bit of time to actually do. Then from all of this and what we know is going to carry over, we have to figure out how much time is available in each LST hour. Not only just for the hour, but how much for each weather condition that we have. So we have poor weather, which is anything below 8 gigahertz. Good weather, which is 8 to 18 and 27 to 50 gigahertz roughly. Excellent weather, which is above 50 gigahertz. And at the same time, we have to remember that fixed and monitoring observations will count against all three, because occasionally you can't move those to avoid good weather or excellent weather. And so we do a 50, 25, 25 split on those, how they count against things. And then to add another twist on top of this, we have to know how many nighttime hours are available, because currently Mustang, Argus, and W-band can only observe at night. So we have to figure out how many night hours occur for each LST, and then how many of those hours are actually available for the night to be scheduled. So it gets quite involved. Then what we do is the TAC wants us to provide pre-grades, recommendations to the TAC. Typically this is, we'll get into this in a minute, how we do it. But this is determined by the GBT schedulers, the GBT chief scientists, and if the director designates any other senior scientists. So it's a small group, 3 or 4 people that get together, review these, and provide recommendations to the TAC. And of course, when there's a conflict, that person doesn't participate in any of the decisions. So typically, the highest grade you can get, A, B, C, are rejected. Depends on what quartile you're in. So if you're in the top quartile, you can get an A. If your proposal winds up in the second quartile, the highest you can get is a B. If you're in the bottom half, the highest you can get is a C. And typically, for anything other than the poor weather conditions, we don't give C's. Usually those are only A's and B's. Most of the time runs out. Occasionally, historically, those proposals haven't done well as far as getting scheduled also. So we go in, we make a first draft of the schedule. We go through, we start at the top of the list, the highest rank, see if they fit in. They take up so much LST time. If they are monitoring or fixed projects, make sure that they can be scheduled. Figure out what maximum grade is. Once that's done, then we update all the LST ranges, the times available at night, various things, and just iterate through as we go down the proposals in the list. And so if we happen to run out of LST time, then we'll bump down. We'll either first try to limit the LST range of a proposal, and if not, then we bump down the grade a level. and then go on and so forth. And if it's a fixture monitoring, if we lower the grade, it might go to pseudo monitoring. They don't get guaranteed time periods on the telescope, but they'll should get enough to carry them through the semester. And then just remember, each session gets its own grade. Yes. Right. Right. Yeah. Then once the schedulers have gone through the first cut of all this, then all the schedulers and the chief scientists and any of the senior scientists get together. They go through those all the pre-assignments, make any adjustments. There's always proposals that lie on weird places. You know, how do we decide whether we bump this one up or down or not? It's not 100% clear, you know, for one person to decide. So we do it as a group. Then all those decisions go as recommendations to the TAC. They're just a guess as to what the TAC is going to say for each proposal. At this point, that's all it is. We're not making any of the final decisions or anything. So, you know, along with that, we have to give the TAC, you know, how often each receiver, our guess is how often each receiver is going to be available, how much time we think is going to be available to schedule new projects, any significant new issues coming up that they have to keep in the back of their mind, along with the pre-grades. And then we do highlight issues of particular proposals, like this could go A, but then it bumps this project down to, you know, from B to C because of the time available. We outline all those decisions for the TAC, and that's simply for efficient meeting. So the TAC can quickly go through proposals that are pretty solid A, they can keep A, it doesn't need much discussion, but proposals that might have had something change from what they expected, they can change. Large proposal telecon, it's a few weeks before the face-to-face TAC meeting. You know, a large proposal can ask for, you know, 1,000 hours. That's a big deal if it's accepted or not accepted on what we can accept from the regular proposals. And so we need to know that ahead of time. So the TAC will make their decisions on large proposals. We'll then reiterate back through any proposals that might be affected from those decisions. And then we give our final reviews to the TAC. The TAC then meets face-to-face for 2 days. They discuss proposals from 5 different telescopes: GBT, VLA, VLBA, high sensitivity array, and the global millimeter VLBI array. We typically discuss triggered proposals first. They take a lot of discussion to sort out any competition between triggers. And also they can have impact, you know, a little bit more impact than regular proposals on other proposals. So we want to get those out of the way. Those are typically the toughest, so get them out of the way first. Then we go through the regular proposals by telescope and by rank, starting at the top going down. Typically, discussions only hinge on the issues that have been highlighted that where things are not clear cut, that they might need to make a change for. The TAC might make changes that then have consequences to other proposals. We work those out at the TAC meeting. TAC comes up with their comments to the PI, which we record and then add to disposition later. And they also go through, you know, if you requested 4 HST orbits, they'll give the thumbs up or thumbs down on that. We pass that on to the HST from the TAC. After the TAC meeting, we actually go to the director's review. This is where the real decisions are made, yes or no, on the proposal. Typically, there's no changes from what the TAC recommends. Occasionally there are, if it's felt that a certain area of new science wasn't given the proper weighting, then maybe a proposal will be selected out and brought up, or different conditions. The director's review typically is the director, the chief scientist, the assistant site directors, and then telescope schedulers and any other staff, such as the head of science review.
Is Chris Pirelli still?
No, this is the not AUI level. This review is not at an AUI level.
Well, or NRAL level. Your director there means Tony Beats.
No, it means the director of each. There's two directors
Okay.
at this point. Yeah.
Okay, so it goes through Jim.
Goes through Jim for the GBT, and the NRO telescopes go through Tony.
But then it's Christopher Lilly.
He's the chief scientist
for
at this
the-
point. Yeah.
for NRA.
All right. Typically the director's review isn't looking to make changes. It's just to make sure that policies and procedures have been followed, discuss any issues raised by the TAC. Occasionally there are programmatical changes, but those are rare. And then at that point, we send you disposition letters, which has all the information, the grades, the hours granted, who your project friend will be for the GBT, your final score out of the science review committee, the TAC and science comments, along with the technical review, and then other information that's important from the observatory to your proposal about how it's going to be scheduled and everything. And just remember, if you feel aggrieved by your final result, you can always appeal to the director at that point. And that's it.
All right, thank you guys. We're getting close to the hour, but we'll go through.
Let's do online first. And
Yeah, as long as people want. There are any questions, please feel free to unmute or raise your hand. But in the meantime, let's go with.
well, Will, did you have one?
Larry.
Okay, it's Larry.
So I was wondering, you're talking about the TAC meets face to face and discusses all the proposals for all telescopes. So let's say I had a proposal for the Galaxy Clusters panel. Are all the telescopes, VLA, GBT, etc., considered in the panel and the TAC discussions together, or are they separated based on telescope?
All right, the question is, at the TAC meeting, are the proposals done by science review panel or by ranking? So we divide them up by telescope. So we'll discuss all the GBT proposals at once, then all the VLA, then all the VLBA. We don't break it up by science panel. We actually go down the linear rank score. So the highest rank one we do first, then the second, third, and on. So we're not, the science review panels, or it's been reviewed and ranked by science category. The TAC doesn't go back and re-review the science or anything at that point. The TAC's just basically looking at, here's our highest rank, can we schedule it, and going on. So the TAC's not redoing any of the science reviews at all.
Can you remind me or give an example of the H rating that's hold?
Right. All right. The question is about if your proposal gets put on hold, H rating. So let's say you have an idea for a great proposal, but it requires a new receiver that doesn't exist yet. But you have funds to build that receiver, or you can get funds if you have an accepted proposal or some various weird combination of things. Or we're building a receiver. We said we have proposals ready. The receiver is going to be delayed. We might actually put the proposal on hold. That means we're going to keep the same final rank, keep the reviews, but not consider it for this semester, but we'll hold it and put it into the pool for next semester. It doesn't get re-reviewed at all. You have the same reviews and everything, but it might just be appropriate that it needs to go in with the next semester's group batch of proposals. So it's, I think in past 15 years, we might have used it 3 times. So it's not very often.
In terms of the normalizing grades, I know that you put everything on the same scale, but it makes sense to use a sigma 3 instead of 2 to maintain a wider distribution, because people use the full grades from 1 to 10 or 0 to 10, but then when you do that equation, you basically squish all the grades back together. I know in the end it doesn't matter because you linearize it, but a lot of the discussion with those SRPs, it can anyway, you're deep weighting individual SRP members by you're basically forcing everything in a very tight, narrow Gaussian distribution. I would recommend a larger normalization to distribute the grades, because basically you have distributed grades, they all come together and they get linearized. So
Yeah.
that's my
The-
recommendation, and I don't know if they will do that.
The statement is that, going to the individual science reviews, having a linear, the standard deviation be 2 rather than 3 is
I would
essentially
think three.
that 3 gives you a broader separation between proposal ranks and everything. Historically, it's only been used as 2. That's what we've inherited from previous systems. And I remember vaguely that there was issues with proposals not falling between 0 and 10 if a bigger distribution was used because of outliers in the distribution. They then really skew things and can easily get greater than 0 or 10. But if you use a narrow distribution, that doesn't happen as much. So it's primarily was chosen because of the outliers. It's not, it's something that could be revisited.
Yeah, no, I just think that. Based on all of
Do you have another question?
it's controversial. I had a comment.
If you do have a question and you'd like to say for later, that as well. Otherwise, if there are no more questions.
Yeah, go ahead.
Then I think we can officially wrap the colloquium. So thank you guys all for attending. Let's give one final round of applause to Toney. And we'll see you all next week for a colloquium by guest speaker Ray Pomerantz, talking about science policy in regards to climate change.